Greetings, this is Puya. This presentation is an introduction to the concept of abstract data type. You are already familiar with the concept of data type. You've seen data types such as integer, float, double, character, and even non-primitive data types such as strings and other classes. Data type basically defines a certain domain of values, also defines operations that are allowed on those values. So for example, an integer data type includes numbers such as -100, -2, 0, +5, +200, etc. The operations that are allowed on those values are, uh, let's say, arithmetic operations such as summation, addition, subtraction, multiplication, division, um, finding the remainder modular, and also logical operations such as greater than, smaller than, and so on, so forth. But for example, on other data types such as a string, you can't do multiplication or division. Like that's not defined on a string data type. Or on doubles or float, you can't find remainder. Like that is not defined for a float or double data type. Variables or objects, each of them are called app instances of data type, and each object has a representation that is not necessarily known to the user. So let's say, like, you've seen binary representations in your previous courses, and you know that, for example, we have different binary representation, two's complement, one's complement, unsigned, and so on. Like, but when we represent, or when we use integer data types, we don't like necessarily care how these values are represented by the computer. The same thing applies to the operations. Like, we don't necessarily care about, like, or like we don't necessarily know how these operations or functions are operated on the values, like such as like multiplication and division and so on. Operations can be realized using operators, functions, methods, and etc. We have two main types of data types: primitive and non-primitive data types. Primitive data types are data types that the programming language already comes with, such as integer, double, character, float, boolean, and variations of those. Non-primitive data types are uh, data types that are basically are like the programming language doesn't come with, and the the programmer, who's the user of the programming language, defines them. In C++, for example, we can have classes, structures, enumerators. These are non-primitive data types. Some people call them simple or complex instead of primitive, non-primitive. In non-primitive data types, the operations, also known as behaviors and values, are not specified in the language itself, but are specified by the programmer. And programmer is person like who uses the programming language. Hence, these data types are also sometimes called user-defined data types. What is abstraction? Abstraction is the process of providing only the essential information to the client or the user and hiding the internal background details. So abstraction basically means like you only provide only the necessary information that the user needs to do the certain operation. We don't care how this is done, like basically like hiding the how to or like how these operations are done. in C++ or other object-oriented programming languages, like a great level of data abstraction is provided through classes. So you already are familiar with concepts such as member functions and member variables, and the access modes, like such as um, private, public, protected. So these, using these access modes and using member variables or functions, basically attributes and methods, programming languages, object-oriented programming language such as programming languages such as C++ provide um, a great level of data abstraction. So it means that you can do certain operation without actually knowing how the class has been implemented internally. So some information is basically hidden from the user, from the client. Another concept that we have in object-oriented programming, and it's a very important concept, it's encapsulation. So encapsulation is basically separating the components into external or public and internal aspects or private aspects. Um, I use this analogy that, for example, when you take a medication like in a capsule, the whatever is inside it, it's hidden from us. We only see the outside. We can only access the inside through the external components, and like the company, pharmaceutical company that makes these capsules, they might like change or modify uh, the internal components without the user's knowledge, without the patient's knowledge. So only external aspects of an object are visible to the other objects in the system in the programming languages sense. Internal aspects are details that should not affect the other parts of the system. So therefore the user shouldn't like know like what's happening inside. Hiding the internal aspects of an object means that they can be changed without requiring changes to the other parts of the system. So like that's why like the user not necessarily need to know about it. So um, similar concept applies to, for example, cell phones. When they get updated, we don't necessarily know like what happened internally, but like the way we use cell phones is the same, remains the same. Some examples of abstraction. So when you drive a car, you have an interface, which is basically the steering wheel, the pedals, gas pedal, brake pedal, like if you drive a manual, clutch pedal. These are available to the user, and like some signals and different things that you have in the car, but we don't necessarily know how the car runs using the steering wheel, like or brake pedal, gas pedal. We don't necessarily know how these are implemented internally in the car, and therefore, for example, if like a new version of the car comes, we don't necessarily know what happened, what changed. We just basically use the same interface that's provided to us. The same concept applies to TV and cell phone. Or if you have a program that is taking care of like library management system, renting a book from the library, there are like many aspects of the program are hidden to the user. Like the user can only see certain things. We don't know how these are implemented. So let's say like we only need to know like the availability of the books, when it is due, and stuff like that. But we don't know how the program, like the user doesn't know how the program was implemented. Um, an abstraction can be also like like an analogy that we can use, it's a list of marks or list of numbers. You have a list that you have to manipulate, but let's say like a list of marks, you want to sort them, you want to search through a mark, you want to find the maximum, minimum, standard deviation, but how this is done, it's hidden with defined operation on those data. So like, let's say like you use software package such as Excel, right? You can sort a column, you can find the average of the data, you can find the maximum, minimum using different operations. But how this is done, how these operations are done, are hidden from the user. Or if you want to go from point A to B, so an abstraction would be just like saying like, oh, go from point A to B, but you can go using different methods, different operations. You can walk, you can take a sky train, you can take a bus, you can drive. So the abstraction is basically just like the high level picture of just going from point A to B. If you ask me, like, for example, like how to pass the course, I would just like say that like, oh, you have to get above 50%. But how you do it, like the way I answered, it's hidden from you. Or in terms of programming language, in integer numbers, as I mentioned, like we know what the integer numbers, but what the integer numbers are, but the way they are implemented, they are hidden from us. Like we don't necessarily know. We use them, but we don't know like how, or like a typical person like doesn't know how, the typical user doesn't know how these are implemented, how these numbers are represented in the compiler or in the computer. Or in terms of C++, let's say like you have an object cout, you know, like what the what this object do, like, you know, the application of it, like it basically displays information on the screen, right? But we don't know how this is done. Or there's a sort function in C++. We don't necessarily know what algorithm is implemented in that sort function. And in different compilers, in different versions of a software, they might change the sorting algorithm without the knowledge of the user. So an abstract data type, in short ADT, is a data type defined by the programmer in terms of its data items, which can be composed of one or more primitive data types, and also their associated underlying operations. But the implementation of that data type is hidden on the principles of data hiding. So abstract data type is looking at something in the point of view of the user. ADT basically describes a container that holds a set of finite number of objects and their associated operations. For example, a list of integer numbers. Okay, a list of integer numbers is an ADT. So you can represent that list using an array or using a linked list. We don't care. When we talk about ADT, we don't care how this is implemented. This is hidden from us. But like you will see that like there's another concept that takes care of implementation. So ADT only cares about representation. Or you can have abstract data type of matrices. You can represent a matrix or a complex number. That can be an abstract data type. But how this is done, it's basically hidden on the principle of, based on the principles of data hiding. ADT also incorporates the mathematical constraints on the application of the operation. So for example, if you want to do matrix operation, there are certain rules that there are certain constraints that you have to follow, or like if you want to do division, you have to follow certain constraints. So like ADT also incorporates those constraints and those requirements. So just to summarize, ADT is a collection of data whose implementation is hidden behind the operations on them. A similar concept to member variables and private member variables, public member functions. And there should be like a nicely defined interface with hidden implementation. Several object-oriented programming languages such as C++, C#, Java, Python, they support ADT construct. So you can see in this picture, that's like what I just mentioned here. ADT is basically a collection of data objects, and the operations that operate on these data objects. It's like a black box. We don't know how these operations are done. As I mentioned, it also like incorporates constraints, or known as preconditions. If you forgot like what preconditions are, like please review preconditions and postconditions. A precondition basically indicates what must be true before the operation, and we have the similar concept called post condition. It basically means like what's going to happen after the operation, what's going to be true after the operation. A good practice when you write a program, when you write a function, is always to have precondition, post condition statements as comments before the function. Specification of ADT indicates what the set of operations do, but it doesn't tell us like how these are implemented. It only concerns with representing the data and not how they are constructed. So ADT definition is based on declaration of the data, first of all, declaration of the associated operations, and encapsulation. So basically hiding the data and hiding the implementation details of the operation from the user, and the operations on the ADT or abstract data type can only be done by calling the appropriate functions that is available to the user through the interface. So why do we want to have abstract data types? Abstract data type has the following advantages. So first of all, it provides some sort of security and reliability so that the user doesn't necessarily access what he or she is not supposed to have access to. So for example, when you buy a TV or when you buy a car, you don't necessarily need to know how these systems work, right? And the user cannot corrupt the data, cannot damage the data that he or she is not supposed to have access to. It also provides some sort of flexibility. So the like basically the programmer can change the implementation, can change the algorithms without any impact on the user's experience of applying the operation. So that's like what's happening in like different versions of, let's say, like an iPhone or Android phones, smartphones. Like there are like multiple changes. There might be like multiple different algorithms that were modified, but the user's experience might not change that much. Like the way they use, like for example, the camera, or the way they call, or the way they connect to internet remains the same. Any change to implementation does not affect the user, like here, like we mean client. When we talk about abstract data types, we don't care like which programming language we're gonna use. Like we just like basically look at the big picture. So it's like independent from the programming language. you can have like one abstract data type and use it like multiple times in different problems in different programming languages. So therefore reduces the coding effort. And it's one of the foundations of object-oriented programming. So like there are some foundations for object-oriented programming, such as abstraction, encapsulation, modularity, and ADT, abstract data type, is one of the foundations of object-oriented programming. Now, another concept that we should know, and this course is called data structures and algorithms. So like we want to know what a data structure is. So we mentioned that ADT, abstract data type, only cares about what needs to be done, but not how this is implemented. As opposed to that, data structure is one step further than ADT and defines the concrete implementation details of ADT. So looking at the problem, looking at the data as the point of view of the programmer. Data structure is not the same as ADT. Some people like feel that they're the same, but they're not the same. Data structure is one step further. ADT is the logical model of the data structure, and ADT is only concerned with like the representation and what needs to be done, but data structure is concerned with how this is done, how this is implemented. Data structure is comprised of a particular way of physically representing, storing, and organizing the collection of the data. An example, an exact step-by-step procedures, also like it is comprised of an exact step-by-step procedure to perform the operation on that collection of data. I know that like you guys are confused or might be bored because this is mainly like a textual and conceptual presentation. Let me give you an example. When I tell you like that we want to implement a list of marks, what I just told you is an abstract data type, a list of marks, a list of integers, a list of doubles, right? We don't know how to implement it, but when I tell you that like, oh, we want to implement it using arrays or using linked lists, that's going to be a data structure. So arrays and linked lists are two examples of data structure. It's a particular, concrete, physical way of representing data. And also like it comes with certain operations that you can do on arrays and linked lists. So for example, sorting. Like we have different algorithms, right? We can have like bubble sort, insertion sort, quick sort, merge sort, and etc. So arrays and linked list are two examples of data structure based on the concept of list. When I tell you a list of data, it's just like a general abstract data type. It's an abstraction concept. But when I tell you that we're going to have an array of integers, that's a data structure. Like we know like how these are going to be implemented. They're going to be in like sequential memory spaces, right? And like we know like what the operations that operate on arrays are. We know how the algorithms, like what kind of algorithms we can implement on arrays or the linked lists. What are the advantages of data structure? So like data structure is basically like what the programmer does, right? Like what the programmer needs to know, like the point of view of the programmer. What abstract data type is the point of view of the user, the client. Data structure are conceptual and concrete ways to organize data for efficient storage, representation, and manipulation, and are used in the design of efficient algorithms. There are essential ingredients of creating fast, powerful, and efficient algorithms. They help to manage and organize data so that it can be used efficiently and effectively. And basically, they make the code much cleaner and easier to understand. So when you have an array or linked list, it's going to be much cleaner and easier and more modular than just like having multiple variables, right? So that's what a data structure is. An interface is basically the functions or the operations that the client has access to. As I mentioned earlier, ADT is an abstraction of a data structure which provides only the interface to the user, and the data structure must adhere to those interface functions. The interface does not give any specific details about how or in what programming language something should be implemented, and it's just a list of operations, or also known as behaviors, that the client has access to. So for example, like in a car, the combination of steering wheel, gas pedal, brake pedal, clutch pedal, and other like monitoring signals that you have are basically the interface that you have access to, right? And they're supposed to operate the way they are implemented by the data structure, right? So as I mentioned, like about the concept of data hiding or encapsulation abstraction, the interface is what's available to the client, but the data structure is not available to the client. It's basically what a programmer has access to. A wall of ADT operation basically isolates data structure from the program that uses it, from the client program. Just to give you a perspective, what we're going to see in this course, we're going to see some abstract data types. So next class, we're going to talk about stacks and queue. Like next week, we're going to see like what a stack is, what a queue is. These are abstract data types that can be implemented using different data structures in different programming languages. When we describe them, we don't care how these are implemented, but a stack or a queue can be implemented using arrays or linked lists. Or another abstract data type that we're going to see in the course are hash maps or dictionaries, that we can implement them using array data structures, or priority queues that can be implemented using heap data structure. In conclusion, the way the program is designed, first of all, we have a logical or mathematical model, an informal algorithm, like we just like know like what needs to be done. Then we create an abstract data type based on that mathematical logical model. So like, let's say like a list of numbers, and a pseudocode. A pseudocode, it's an algorithm that is basically not written in any programming languages, but provides like the operation details. And then how the program is implemented, basically the data is represented and implemented using data structure, and the algorithms are operating on those data that's available in the data structure. So that's what the data structure and a program is. A program basically uses the data and the algorithm to do the certain operation that needs to be done. That's all about abstract data type. This was a very short topic. Thank you so much.